Saxon Advanced Math Lesson 56C. This is Systems of Inequalities. Now, I went ahead and took a little different direction than they started with here, so bear with me just for a moment, and then we'll reconverge on one of their examples. I have a y is greater than 2x minus 3 and y is less than negative 1/2 x plus 6. And I have four regions these lines break the plane into. And let's just go ahead and talk about it. But first of all, graphing these. Of course, I go down 3, then my rise over my run is up 2 over 1. And then I made a dotted line. And we'll explain why that is in just a minute. Well, let's go ahead and do it now. Y is greater than this line. This is the line. That means it can't be equal to the line, so I used a dotted line. And I say this region here would be greater than this line. Then I said y is less than negative 1/2 x plus 6. So I say up 6, right? Down 1 over 2. There's my line there. And I say, well, where's the region that is less than this line, but greater than this line? Now, remember that lines break planes into two half planes. And intersecting lines break planes into 4 segments, right? Or 4 sectors, or pieces, if you want to think of it that way. So I have this is greater than this line and greater than this line. C is less than this line, but greater than this line. D is less than this line and less than this line. And A is greater than this one and less than this one. Well, in order to work for these equations, greater than this line, less than this line is letter A. And it's that simple. It's really that easy. And then we're going to break these into these pieces. Now, the next one, 56.7, the example, and I went ahead and skipped to what would be considered as some as the hardest example here, although once you see it, you'll realize how simple these really are. Which one of these, A, B, C, or D, these areas satisfy my system of inequalities? Well, the bar underneath means that these are going to be solid lines instead of dotted lines, right? So that was, I didn't have a bar, so these were dotted. These are solid because it can equal the line itself. So the regions that I'm looking at, region A would be outside the circle above the line. Region B is above the line inside the circle. Region C is under the line inside the circle, and region D is outside the circle and under the line. So I have 4 possibilities of the regions that it works in. And I'm looking at this, I'm saying, well, my equation, my circle, I recognize this is my origin, right? A circle, so it doesn't move off the origin, which this one doesn't. And it's less than a radius of 4, yep, okay, so, but it's less than. Well, it's less than that radius. That's the key that I'm going to look at for these circles. So it's going to be inside the circle. If it was greater than the radius, it would be outside the circle. So I'm looking at this realizing it's inside the circle, and y is greater than or equal to x. So that means that it is above or equal to the line y equals x. Well, y equals x, graphs like this. So above the line, inside the circle, and the only logical answer, therefore, is B. And these are the regions the region that satisfies both inequalities at the same time. Now, once again, if I just have one of these, A, B, and C both satisfy this, right? A and B both satisfy this. So if the only one that has satisfying both of them is B. And that's the way to think of that.